Hello everyone, my name is Matthew Burns and this is my design project for EE310 Digital Systems and Embedded Control. I do apologize for the noise in the background. I'm filming this at the university library, so just bear with me. So I decided to simulate a couple of flight systems, namely the landing gear, flaps, and a low altitude warning. Down at the bottom you can see some pictures of that. I couldn't find a good picture of a low altitude alert, so spoilers. So for the landing gear system, it only needs to be up or down. It doesn't need to be much input beyond that, so a switch should be able to suffice as far as the user input. So if the switch is in the up position, the gear should go up to the up position. If the switch is flipped to the down position, the gear should go to the down position. And then we should continuously check as we're executing the program in case the user changes their mind halfway through. So as far as the landing gear itself, that's just going to be a servo motor and have some LEDs that will correspond to the position of the servo. So a red LED will mean that the gear is all the way up, a green LED will mean that the gear is all the way down, and yellow is somewhere in between the two. Flaps, on the other hand, need to have a whole lot more positions available to the pilot. They can be all the way up, they can be all the way down, or they can be somewhere in between. It just depends on what the pilot's needing. Do they need more drag? Do they need more lift? One point that I want to make clear is in the bottom right picture, I'm not simulating the parts that are on the top of the wings. I'm only doing the part that's on the bottom. So the next system will be the low altitude system, or low altitude alert. I'll do that with a ultrasonic sensor and more LEDs. So if you're far away, no LEDs are on. If you're getting closer, one LED will come on. If you get closer still, both of them will turn on. But if you're right up against it, then the LEDs will be flashing, trying to get your attention. So on to actually building it. On the left, you can see the servo that will be representing the landing gear and the switch along with the 3 LEDs. On the right, this switch did not want to stay into the breadboard, so I added in an LED so I could see exactly when this switch left the breadboard. That helped with debugging later on. So here's the code for that system. On the left, you have the relationship between the switch and the motor. When the switch goes high, it's going to execute the routine up here. But if the switch goes low, it's going to execute the routine down here. That's why when the switch left the breadboard, I was having the error, because it would actually have the motor go backwards instead of where I wanted it to go. On the right is the code for the LEDs. When it's all the way up, the red LED will be on. When it's moving, where the position is between the up and down, the yellow LED will be on. And when it's all the way down, the green LED will be on. If for some reason the servo motor is in a position that's outside of 0 and 90, then all 3 LEDs will come on, letting me know that there's an error with the motor. So for the flaps, this one was a good bit simpler. It's just 2 servo motors controlled by a potentiometer. Now, these servos are a different model than the one that was used for the landing gear. That little bit of information will come in handy later on. Last but not least was the low altitude alarm. It's the ultrasonic sensor and the 2 accompanying red LEDs. Here's the code for that one. On the left, you have the ultrasonic sensor sending out a pulse, then changing that pulse into time, and using that time to find the distance. Now I had to divide that distance by 2 because the sound is going all the way there and back. That threw me off for a couple of minutes, so I decided to include a picture of that. Then on the right, you have the controls for the LEDs. You're far away, nothing's happening. Getting closer, one turns on. Closer still, both of them turn on. And if you're right up against it, then the LEDs are going to be flashing at you. Lastly, I built a display for the motors and the potentiometer out of particle board. And on the top, we have the landing gear. On the bottom, or in the middle, we have the flaps. On the bottom, that potentiometer will be controlling those flaps. So unfortunately, Zoom doesn't let me record multiple audio sources at once, so I'm just gonna have to mute this video and then talk over it. Hopefully I can get my voice to line up with the recording. So up at the top, we have our landing gear, and that will be controlled by the switch, and it'll have the 3 accompanying LEDs, green, yellow, and red. So when you flip the switch, the motor moves, flip the switch back, and the motor goes back. The LEDs will indicate that position. Green is one position, red is the other, yellow is somewhere in between. Now that switch, like I said, did not want to stay in, so even though it's in the high position, it would give a low signal. That'll just require more debugging, maybe a better switch. All right, next will be the flaps. And they're controlled by the potentiometer down at the bottom. Now these these motors are a little bit jittery. They're shaking some. As I said, they are a different model than the landing gear servo up at the top. I actually plugged in the top servo into the routine or into the ports that control the flaps, and it ran that program pretty smoothly. So that tells me it's not an issue with the code or the Arduino, it's just an issue with those 2 motors. Up next will be the low altitude system controlled or involving the ultrasonic sensor and the 2 red LEDs. So when you're far away, nothing is happening. You hit 15, one turns on. Moving up to 10, you'll have both LEDs turn on, and at 5, they'll start flashing. Now, interestingly enough, if the device, the screwdriver case there, is held at an angle, you get an incorrect reading. This technology is used in stealth fighter jets, or stealth aircraft. The fuselages will be built with weird angles as to confuse the enemy radar. That just deals with the fact that the sound coming back to it, the frequency and the pulse coming back to it is going at a not direct angle. So, future work, I would like to 3D print the display rather than just make it out of particle board. That would make it a lot stronger and a bit more precise. I'd also like to replace the 2 shaky motors with motors that don't shake. Had a bit more time, then I would expand upon into incorporating an LCD rather than just LEDs. Problem with that is I'm gonna need a bigger Arduino board. Currently, I only have 3 digital pins left, and the LCD requires, I wanna say 8. I would have to pull out all of the other LEDs in order to have the minimum required pins for the LCD. But if I wanted them to work together, then I need a bigger board. And then there's the references for the ultrasonic sensor. So that's it.